Hey, my name is Steven, and today I'll be reviewing what I've done for Lab 3 called Magnetic Field of a Bar Magnet. The purpose of this lab is to basically visualize a magnetic field using bar magnets. The only concept that we're going to be using is what we already know about magnetic fields, the equation and such. And the only materials that we're going to be using will be the phone with the app on it, a couple pieces of tape, some rulers, and of course a bar magnet. So throughout the experiment, what we're trying to do is basically try to get a specific magnetic field value when it equals 20 or 70 or whatever by using the sensor on our phone and of course a bar magnet. And while we're doing that, we're also recording the distance between the bar magnet and our phone and recording that for our spreadsheet. And basically, as you can see with my data, you can see that there's an inverse relationship with the distance and the magnetic field value. When the magnetic field value increases by 50, the distance is basically halved each and every time. So it kind of supports what's happening within the magnetic field equation, where when distance is increased, so the magnetic field will be decreased. But just a quick disclaimer as well, I do realize that my data is wrong. Unfortunately, I've been doing this lab multiple times and I'm just getting the same crap over and over again, unfortunately. So just keep that in mind with the results I'm getting, as well as the coding and the model that comes up. It's going to be wrong. but the results that I do get, by using the line of best fits, I do get an ln of k of around 2.71. And by using that k value, I do manage to get a mu value of 7.37 e to the sixth. So for the second part of the lab, I positioned my sensor at a 45-degree angle relative to the bar magnet, and it was approximately 10 centimeters away, both vertically and horizontally. And this resulted in being a BNet value of 39.5 each and every attempt that I got, which was great. But I did do some extra experimenting with the magnets for my third attempt just to see what would happen. And when I basically just flipped the magnet around 180 degrees, so like the closest pole would change, the closest pole to the sensor, I ended up getting a BX and BY value that's different from all my other attempts. So as you can see for the third attempt, for the BX value, it actually changed sign, and for the BY value, it changed considerably. But the BNet value actually stayed the same. So it didn't really matter which pole was closest to the sensor, you would still end up getting the same results for the BNet, but BX and BY would change. And for the coding portion, the values for the arrows, unfortunately, were just too big, but I did try to scale it so it is properly representing what's actually happening. So as you can see, for the 4 arrows pointing in the negative x direction, those represent all the perpendicular magnetic fields that are happening. And for the ones on axis, they are pointing in the positive x direction. And all of that should happen when trying to use a positive mu value. Unfortunately, for my 45-degree angle arrow, unfortunately, I'm getting a negative x value. I'm not too sure what's happening with that. I tried to see what was going on in my code, and unfortunately, I'm still not able to spot it. So, but yeah, other than that, everything does seem to be correct. But however, the values that I have for B, unfortunately, were just too big. So for the code, my BNet would actually be around 234. And comparing that to 39.5, that's pretty wrong. So some additional observations that I made during the lab. I realized that if I didn't align my phone correctly, I would actually start getting a lot bigger values for the magnetic fields. And I believe this is due to me both measuring the bar magnet as well as the Earth field. So it's kind of just adding on top of what I'm already trying to measure. And the second observation that I also made was using 2 magnets and what would happen. So I actually did a little experiment with that, and I noticed that the magnetic field will also increase from that as well. And this is due to, I believe, to there being a higher value for the U. And that's why it's causing a higher B net value as well as BX and BY and BZ.